Hello again, everybody. In this video, we're going to perform character recognition via the K nearest neighbors algorithm in OpenCV, and we're going to go get to the implementation details shortly. We have a nice example project to go through, but before we do that, first I'm going to give you a quick overview of the KNN algorithm for those that may not be familiar with it. I'm not going to get into too much detail as far as the algorithm here. This is just a broad, very high-level overview of the general steps involved and what the algorithm is all about. So let's say we're trying to detect the digits 0 through 9. So for any machine learning process, of course, you have to have a training data set. So let's say we had a training data set of 5 each of the characters 0 through 9. So for example, we would have 5 zeros, 5 ones, 5 twos, etc. through 5 nines. So of course, 10 digits times 5 training images of each digit, we would have 50 total training images. And then also to have just to have some numbers to work with, we're going to actually use different numbers when we implement this momentarily. But just for the purposes of this slide, suppose that we're going to resize each of the training images to be 10 pixels by 10 pixels. So in other words, each image would have a total area of 100 pixels, and we'll do the same when we're attempting to identify in our test set later on. So as a result of the training process, what we're going to have is we're going to have two parallel data structures. We're going to have one will be the set of images, of course, the 50 images, and then the other one will be a set of numbers indicating which group or classification, either of these terms are pretty common for machine learning, either is acceptable, which group or classification each corresponding image is in. So for example, we'll have a classifications data structure that's going to be, in this case, for example, suppose the first 5 images were the 5 zeros, so the classifications data structure would be 0, 0, 0, 0, 0, and then the 5 ones, 5 twos, etc. through 5 nines, and then we'd have our 50 images corresponding. And once the training process is done, then we could begin testing, that is to say, identifying characters under test. So let's suppose that we're trying to identify an unknown digit x. And what we would start with doing is, or the KNN algorithm itself would start doing, is it would identify the nearest neighbors in order. So in other words, the terminology nearest neighbor means the best match to x out of the training set. So for example, let's say that when we compared x to our training set, that the best possible match, we found that 99 of the 100 pixels in x matched one of the training images that happened to be a 0. So that would be the nearest neighbor. Let's suppose that the second best match, 97 of the pixels matched, and that happened to be an 8. And the third best match, 96 of the pixels matched, and that happened to be an 8, and so on for the fourth and fifth best match, once again being zeros, and then all the way down to the second worst and worst matches, only 4 and 2 of the pixels matched. And let's suppose that was for completely different numbers. So the next thing we would have to consider is what is our k value. K referring to number of nearest neighbors. So in our example data set here, let's suppose that we set k to be 1. Then we would determine that x is 0 because we're only looking at the one nearest neighbor, and that happened to be a 0. Let's say we set k equals 3. Well, in that case, we would have 0 but then 2 8s. So 2 out of these 3 would be 8s. So then we would say that x is an 8. And then, for example, if we chose k to be 5, then we would have 3 zeros out of 5, so then we would say k equals 5. So that's sort of an overview of how the KNN algorithm works. And one specific thing that I should point out here as far as choosing k value, for relatively obvious reasons, you don't want to choose an even number. For example, if you chose k to be 2, well, would it be a 0 or an 8? That's not necessarily clear. So to avoid ties like that, you want to choose k to be odd. And the other thing, of course, is that you cannot have a k value that is larger than the smallest number of samples for any of your classes. So for example, suppose we had only 3 images of the character 0, but then suppose we had 50 images of 1, 2, 3, 4, etc. through 9. Well, we still couldn't pick a k larger than, at the absolute largest, 3, because we only have 3 zeros. So that is a limitation to keep in mind in your data set. Now, in the example program that we're going to get to, we're going to work with very simplified data. If you were going to do this in a production environment, you would test with different fonts, different sizes. If you were going to read people's handwriting, you would test thousands of different handwriting samples. But we're going to work with a data set where we have the digits 0 through 9, and we simply have one instance of each to keep the program and the training time down. And one additional thing that I should also mention is that some of you may have heard of SVM, that's short for Support Vector Machine, which is also a machine learning algorithm that's not all that different from KNN. really probably the most fundamental difference between SVM and KNN is that effectively with SVM, well, first let's consider KNN. What we did here is we compared all of image X to all of image 1 through 50 in our training set. If you had a really large size training set or huge images, that would take a long time. What SVM fundamentally does, it's different. It does multiple other things different, but to me the biggest difference is that with SVM you would find the key points of X, and then you would find the key points of the training images, and then you would simply compare key points. So if you had images that were, say, 1,000,000 pixels, or very large images, and a huge set of images, it would still be workable time-wise. I may do a future video on SVM, or I may do that as my next video. I'm not really sure. If people have interest in that, maybe post in the comments. But in any case, for now, let's get to implementation of KNN. Okay, so if we go to my GitHub page, and I'll just type it in case you don't have it bookmarked, GitHub microcontrollers, microcontrollers, and more. And there we go, pops right up, and you probably want to go ahead and bookmark this if you have not already. Let's see, repositories. And one additional thing I should mention is OpenCV 2.4.11 Windows Installation Guide. I'm going to suppose going forward in this video that you've already followed the steps in Installation Cheat Sheet 1 if you'd like to use C++, or Installation Cheat Sheet 2 if you would like to use Python. And on my YouTube channel, I do have corresponding videos for those installations as well, so please follow those through if you have not had a chance to do that already. And so what we're going to do continuing for this project is OpenCV KNN character recognition machine learning. And first let's just take a quick overview at everything that's here. So KNN overview, this is simply that slide I was just showing earlier. And then we have two programs here, and a C++ version and a Python of each. The Python version of each. The first program rather that we're working with is generatedata.cpp or generatedata.py, whichever you prefer. And then the second program is going to be trainandtest.cpp or trainandtest.py. And then the other contents here, README is essentially, the README just says refer to the video, which you're already watching, so honestly you don't really need to go through that. And there's two more here, testnumbers.png and trainingnumbers.png. So training numbers is simply 0 through 9 written out. And again, for a production grade program you would need a much bigger training set than this, but just for our simple example today this will work. And then test numbers this is what we're going to detect the characters in, and I just randomly chose pi as a good choice of just a string of numbers to use. You can use any string of numbers that you like. And also, just to show you that there's nothing special about these two particular images, rather than downloading them off of here, which you can do to save time if you like, but rather than doing that for the demonstration today, we'll actually recreate those via screenshots. We'll get to that in a moment. So let's start with generate data.cpp, and then we're going to go to raw so we can copy and paste, and go ahead and fire up Visual Studio. And then we're going to make a new project here, file new project. And let's see, here's the installation cheat sheet that I mentioned earlier. This is installation cheat sheet 1. We're going to use this to configure our project here. So let's call it generate data. So let's see, Visual C++, Windows 32 console application. Let's call this generate data 1, usual location, uncheck those, next, uncheck those, empty project, console application, and finish. And when it comes up, add new item, C++ file, call it the same name as the project, add, and back to the GitHub page here, Control A, Control C, and let's make that just a little smaller, Control V, and we're going to get a whole bunch of red lines because we have not yet told Visual Studio where to find OpenCV. So at this point I'm just going to repeat the same steps as in the installation guide here. So configuration, Visual C++ directories, include directories, edit, and there's our include directory, then library directory, edit, and I'm simply copying and pasting out of the installation cheat sheet 1 if you're wondering. Here's what I have on the other screen, just copying and pasting out of there. So there's library directory, and then we're going to go to linker, input, and copy and paste our OpenCV libraries into there, and then apply and OK, and there we go, all our red lines disappeared. Okay, and let's see if we go to where we just made that project, so Visual Studio 2013 Pro CPP, generate data 1. Okay, so we're going to need an image in here to recognize characters in. So let's go ahead and make the image now. And we're just going to do this here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'd suggest a pretty good size font here. Let's go maybe 28. Anything in the 20s should be fine. Make it nice and big. And then I'm going to press Control Print Screen. And then fire up Microsoft Paint. And then go ahead and paste in that screen print. There's my other screen momentarily. Here's the screen I'm working on currently in the video. And then if we draw a box around these and choose crop, and then we do save, and we have to save it to that Visual C++ project directory, so 2013 Progs, CPP, generate data 1, save it, and we'll rename it in a second. Okay, we can minimize that for the moment. And if we look down the program here, training numbers.png, that's the name we're looking for. So we need to change this from untitled.png to training numbers.png so our C++ program can find it. And I just paused for a second to change back to the large cursor. Hopefully that makes this a little bit easier for anybody viewing this video in anything less than 1080p resolution. So if we didn't forget anything, we should be able to start that up, and there we go. Okay, so here's the windows that we have up. This is the image simply reproduced here. So this image here is all that this is, and then we've additionally drawn a red box around the current character that we're trying to recognize. This is the threshold image. We'll get to that in code a little bit later, but this is just printing it to prove out that the thresholding process worked okay. And then these two images here, the larger of these two 7s that's this 7 cropped out, and the smaller of the two 7s is this top one resized to a fixed size. Again, we'll get to that later in code. So now at this point I'm simply going to call out the numbers as I'm keying them in here. 7, 5, 4, 9, 8, 6, 3, 2, 1, and 0. Training complete, press any key to continue. So now if we go back to that same directory, we're going to see two files here, classifications.xml and images.xml, that were not there before. And these are in XML file format. This is the data we just entered. These are the numbers 0 through 9. Of course, they're higher numbers simply because of the conversion to the ASCII number matching that character. And you'll notice there's a decimal after each. The KNN object requires things to be passed in float format. We'll get to that in the second program, but that's the reason for the decimal, is because they're floats. But other than that, that's the data, and the ASCII conversion, of course, that's the data we entered. And now images, of course, is going to be the 10 images, and they're we'll get to this more in a moment later, but that's a fixed width of 20 and a fixed height of 30. So it's 10 images that are 20 by 30, so of course images is going to be much more voluminous in terms of data. And these numbers here are simply our images, and once again there's a dot after each number because they have to be stored as floating point. So getting classifications and images was the idea behind that, so that was successful. So now let's go to, I'm just going to open up a second Visual Studio here. Easier to have two open at once, I think. So now we're going to go back to here, and we're going to go to train and test.cpp raw, and then I'll just be copying and pasting out of this. So train and test. So X out of that. File, new, project, Win32 console application, train and test 1, usual location, uncheck those, next, uncheck those, empty project, console application. Okay, that's good. And now we're going to make our C++ file, add new item. It's test1 CPP. Okay, that's good. Make that a little smaller. And Control A, Control C, and Control V. And now if we check here, train and test 1. So we're going to need to add some things to this directory for the program to work. The first thing that we're going to need to do is we're going to copy classifications and images over to train and test, so that data is available to train and test. And now the second thing is we're going to need to add an image here to detect characters in. So you could pick any number sequence you like. Just common number sequence everybody's heard of is pi, so let's use that. So let's see if we bring up Notepad. and we just paste over that, and then control print screen, and then start paint, select, paste that in there, move over here, draw a box around that, choose crop, and then save, and we'll save that to Visual Studio 2013 Prog CPP train and test. For now we'll just save it as untitled. We're going to have to rename it, of course. Okay, we can close that. Well, let's just minimize Notepad for the moment. Okay, and we're going to have to rename that to, whoops, we didn't put in our references yet. You have to do that as well. Training images. Okay, we're going to rename our image to test_numbers. So now our program will be able to find that, and there's our image that we just made. And let's go ahead and do our references from the cheat sheet to get rid of all these red underlines here. So project test1 properties, and let's see here, include directory, configuration properties, Visual C++ directories, include, edit, new, paste, and library directory is next. Library directory, whoops, edit, and new, paste, and now linker, input, and copy and paste in our libraries. Additional dependencies, edit, paste, apply, okay, and if I didn't miss a step there, good, all our red underlines are gone. And we have the 3 additions to this directory that the program needs: classifications.xml, images.xml, and test numbers. So we should be able to go ahead and run it now. If I didn't forget anything, good. Okay. Hopefully most people are able to view this in 1080p. If not, it might be hard to see the numbers. But in this command line here, I'll move them like this so you can see them both at the same time. In this command line window, these numbers here, that is a string that's stored as a string inside the program. And this window on the left here is the image, which has each of the characters or numbers that was found. The bounding rectangle of those is drawn in green. And as you can see, it did work here. Well, there's no decimal. Of course, the dot is eliminated because we weren't trying to recognize anything except 0 through 9. And the test that we used in this program for that is the area at least 100. Of course, the area of a dot is not 100. That's not big enough. So that was taken out. But as you can see, it did work. 3141592655359. So that was successful. And some of you might be kind of looking at this and thinking, well, that's not very impressive. You just had a plain Jane image with numbers in it, and then you converted it to a string. Well, okay, that's one way to look at it. But on the other hand, this would work in a production environment. You would simply, if adapted correctly, you would need a much bigger data set. You would need different font sizes, all different fonts that you could possibly think of. If you were going to read something that's handwritten, you would need thousands of handwritten samples. There are many handwritten samples of digits available in the OpenCV samples directory, I might add, so you wouldn't have to do them from scratch. You could read them out of there. And then, of course, if you were reading numbers in a scene, you would have to do a tremendous amount of pre-processing to get down to an image this clean. And it might not be possible to get down to an image quite as perfect as this, but with enough pre-processing, and depending on how familiar you were with the scene or the constraints of it, you hopefully could get pretty close and then get good character recognition. So all those extra steps we haven't really got into today, just to keep the example as simple as possible. But as you can see, it is possible to read without too much difficulty using OpenCV and KNN the characters in an image. So we've got that working for us. Let's go ahead and take a quick look at the Python version before we get into the code too much. And I think we can just save it straight to the desktop here. So let's see, move that out of the way. And we'll do this, back one here, and okay, generate data.py and raw. And we'll grab the name there and new text document. And whoops, okay, that's not quite gonna work. Just a moment. Format, let's see, font, go back down to 10 here. There we go. It's got some extra characters in there, copying and pasting, so rename. That's much better. Yes, we'd like to change it. And then we're going to also take a look at the program train and test.py and raw, and we'll grab the name here minimize that and paste that to there. Take out any extra characters. New text document. Paste. Yes, we're sure we want to change the file extension. And let's go ahead and use the image, or let's use both images that we just made. So this is back in the C++ example here. So generate data, we're going to move training numbers out to here, copy it out rather, and then train and test, we'll copy out test numbers here as well. And so again, those are just the same as before. There's training numbers and there's test numbers. And now we need to get the programs themselves. So let's go ahead and open both of these up in PyCharm. Of course, they'll be blank. And while we're waiting for PyCharm to start, we'll go to generate data here and then raw. And yes, we know new version of PyCharm available. Minimize that and now open train and test in PyCharm as well. And this is generate data, Control A, Control C. And generate data, Control V. And then the same for train and test. So if we go back here, back one more, train and test.py, raw, Control A, Control C. And yes, we want to unlock all files. And I'm just making sure here, final check that I didn't miss anything. All we need for the first program is the training numbers. Yep, that's there. And as soon as we run generate data, over here we will see those two same text files appear with the training data in it. So let's go ahead and run that. And we're going to run generate data. Yes, okay. So I'm just going to call the numbers out as I type them in. As you see, there's the same. Maybe I'll just move these around here so it's a little more clear. This is the same for Windows as was pulled up in the C++ program. So 7, 5, 4, 9, 8, 6, 3, 2, 1, and 0. And there we go. There's our two files that we needed. Let's just move these over here so they're all grouped together. Okay. And now if we do train and test, I always like to move this window over to the right. And now if we run train and test, and hopefully I didn't forget anything. Okay, there we go. So I'll make this a little bit bigger here so you can see it. I know not everybody's probably watching this in 1080p, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 clicks bigger, that should be sufficient. And as you can see, this is the string that's actually inside our program, just printed out to the prompt here. And here's our image, and as you can see, once again, we have a successful read, 314.159.265.359, less, of course, the decimal point, which we weren't trying to read. So that worked out pretty well, and I'm just going to resize this back down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's good enough. And the code in the Python version versus the C++ version is essentially just a translation from one to the other. So let's go through the C++ version. But before we do that, I guess really the only thing that's substantially different between them is that because in Python with OpenCV, two images are stored as numpy arrays. So the part at the end of the first program here to write the two parallel data structures, let's pull this up here. To write these, our classifications data structure and our image data structure, when we write those out to a file, the Python code to do that as numpy arrays, here there's where we're writing them to file, and then here's where we're reading them to file, is a little bit different than the C++ code. Other than that, the two programs are just a straight translation from C++ to Python. So to save some time, we'll just go through the C++ code. So let's check generate data first. And when I write this code, I try to make everything, sometimes the spacing gets a little goobered up here with the copying and pasting. That should be over there a little bit. I try to write this code to be as readable as possible. I try to use very intuitive variable names and comment things pretty thoroughly, so I don't think we need to go through it line by line in too much detail, but let's just take a quick overview skim through it. So here we have our includes, 3 global constants, so minimum contour area. So again, the only checks we're doing in these programs to see if something is a valid contour, and then before we pick a digit to assign to it, is we're making sure it has an area of at least 100. Obviously in a production grade program you would have to do far more checks than that, but just for our simplified example today that works okay. And then we're going to we have to satisfy the KNN objects requirements. We have to pass in, when we pass in our set of training images, they all have to be the same size, and our image under test also has to be the same size as well. So we'll define these constants for resized image width and height. Then we declare a number of images, and then contours and hierarchy, and classification ints. That is essentially this data structure here, the numeric classifications. And then training images is, of course, the corresponding data structure here. And then valid characters is our list of characters that we're trying to recognize, 0 through 9. So you could see if you were going to add, say, upper and lowercase letters, it would be very simple just to add here all the letters of the alphabet, and then you could recognize letters as well. So this program definitely could scale up if that's something that you're interested in. So then we read in the training image, make sure it's not empty, and then we convert to grayscale, blur, call adaptive threshold to get a black and white image. And that was the threshold image that we showed on the screen earlier. That's this line here showing that. We make a copy of the threshold image to pass into fine contours. You always want to make a copy of the image when passing into fine contours, because fine contours does modify the image that you pass in. And then once we found our contours, we loop through each contour, and we get the bounding rectangle. That was the red in the first program and then green in the second program, rectangle that you saw around each of the numbers. They were red, of course, as we were entering the keying in the numbers one by one, and then green in the second program because we could just show all at once which contours were found. And then this line here draws a rectangle around the found contour. And then we, out of the thresh image, we focus on the ROI of the current contour by passing in the bounding rect. And then we resize the ROI to ROI resized. And then we show our 3 images here just for user reference. Then we get the key press here, and as long as escape wasn't pressed, of course we would exit the program if escape was pressed. Supposing that it wasn't, then we're going to check if the key that was pressed, with this line here, we're checking if the key that was pressed was that one of these. And if it was, then we add to our 2 data structures via these lines here, push back and push back. And I should mention here, mat classification ints and then mat training images. You might at first look at this and think, if classification list is a list of integers, wouldn't it have made more sense to use, say, a vector of integers or an array of integers? And then for the training images, wouldn't it have made more sense to use a vector of images rather than just a single image and then treating it as though it's a vector with this pushback call here? You may suppose it would have made more sense to do that, but what we're going to find, and we'll get to the second program in a minute where we'll see this in more detail, but in the call to the KNN objects train function, you have to pass in a single mat for both your classification numbers and your training images. So you essentially have to append multiple images via pushback or multiple numbers via pushback onto an instance of just one mat. That's kind of odd, but the KNN object requires it in that format. And from that point on, we're going to write out our 2 data structures to file. And OpenCV provides this very helpful file storage class for such purposes. This syntax is pretty straightforward here. Please see the comments if anything is unclear, but I think I've commented it pretty well. So at this point, we've got our 2 files, our 2 data structures rather, written out to files. So classifications and images was successfully created through here, and now we can jump into train and test. So in train and test, it's very similar to generate data. Really the only major difference is that we introduce a class here, and the reason for that is that we have to sort the contours that we find from left to right to display the final number from left to right. You may have noticed when we were entering keying in the digits to begin with, when we were running generate data, find contours doesn't work from the left of the image to the right of the image necessarily or at all. In fact, I think it started in the middle and then it jumped to the right side and then back to the left. So but we wanted to show, if pi is 3.14159, we have to show the numbers in that order, not in a mixed up order. Then it'll look like we didn't detect the digits correctly. So to sort the contours, we would have to sort the contours and then also the bounding rectangles that match to them, since we're going to sort the contours based on the x position of the bounding rectangles. and then we would have two separate data structures, and if we sorted one, we would have to then sort the other one to match it. So at that point, it's more straightforward just to put everything in a class and then sort the instances of that class after you declare a vector of them. So that's what we have here. We have the contour, the matching bounding rect, and then as long as we're declaring a class, we might as well put some other functionality in it. So here's the area of the contour, and then here's our function for check if contour is valid, and all we're doing is checking if the area of the contour is at least 100. Again, in a production grade program, you would of course need substantially more checks than that, but just for our simple example today, it'll work okay. And then this function here allows us to sort a vector of contour with data types by the bounding rectangle's x position. And we'll get to that in a moment. So now we jump into main. We declare a vector of all contours with data and then valid contours with data. And here we read in the training classifications and the training images, and those are essentially the reverse or the corresponding functions to the functionality at the bottom of generate data. And now we're finally ready to train. So we instantiate the KNN object here, and then we call train. Once again, the commenting sometimes doesn't quite hold when you're copying and pasting in, but I think you get the idea. And then after only these two lines here, instantiate and train, now we're ready to test. So this will look very similar to the previous program, more or less the same steps. So we read in the image test numbers. That was this number, this image right here, I should say. And then we declare our images to work with, convert to grayscale, blur, call adaptive threshold, make a clone of that to pass in defined contours. That finds us our contours. Then in this for loop here, we're looping through the contours that we just found in find contours, and we're assigning them, we're essentially populating each member variable of contour with data after we declare a contour with data, and then we're appending that to all contours with data. Then in the next for loop, we're going through all contours with data, and if the contour is valid, then we're appending that to a vector of valid contours with data. So when we get down to here, valid contours with data will contain the valid contours and only the valid contours. So this function will sort the contours from left to right by the bounding rectangle's x position, and you'll notice we call this here, which is what we were defining here. So this allows us to sort by the bounding rectangle's top left x position. And let's see, where's that sort line again? Okay, there's where we left off. Then we declare the final string. That's what we're going to print out to the command prompt at the end, as you saw. And then we loop through each of the valid contours. We draw a green rectangle around the current contour, and then we get the region of interest, so that being the current contour, in other words the current character we're looking at the moment. Then we resize that to that 20 by 30 size, and then here we do some conversions to appease the KNN object's requirements as far as data type. So we're going to convert ROI resized to a mat, but using float data types there. And we also have to, okay, commenting got a little obscure here again. That should be like that. And we also have to call this mat ROI of floats and reshape it to one-dimensional here with this call to reshape. And then we can pass that into the KNN object's find nearest function, and then the second parameter here is simply the k value, and since we have a sample size of only 1 for each character, we have to use a k value of no higher than 1. In a production grade program, you might have, say, 30 of each character, and then you could use a k value of maybe 5, 7, 9, 11, something in that range. And then that will return, the KNN object's find nearest function will return the current character in the form of a float. So we simply convert that to an integer and then convert it to a character and append it to our final string. And then once we've looped through this for loop here, once we've gone through all our valid contours, then we show the final string to the command prompt, and then also we show the image with the green boxes drawn around the characters, and that concludes the program. Hopefully that was helpful for anybody out there trying to get started in character recognition or machine learning or both with OpenCV. I don't really have any for certain concrete ideas in mind yet for next video. If anybody has anything in mind, anything they'd like to see, please post in the comments, and I'll see everybody in the next one.